I'm Anil Kumar. In this video, we'll talk about coplanar vectors. We'll begin by understanding basic concepts about coplanar vectors. Then we will see how a vector can be written as combination of other two if all three are coplanar. Scalar triple product is a good strategy to figure out if the given vectors are coplanar or not. And then we'll have few multiple choice questions to understand our knowledge about coplanar vectors. Now let me begin by giving you example. Let us say if I have two vectors, right? So vector A given here in this color and the other vector kind of like this. Now any two vectors given to us can always form a plane, right? So let's say we have a vector u and a vector v. Then two vectors will form a plane. If I draw them on this paper, in that case, we are sure that the plane is the plane of the paper. Now if I am given the third vector w, how do we know that this vector also lies in the plane of this paper? That is what we are going to discuss, right? If it lies in this plane itself, then we will say that all three vectors are coplanar, correct? So coplanar basically means in the same plane. That is the meaning of the word coplanar, correct? In the same plane. Now, one strategy to figure out whether W is in the same plane as U and V is to form linear combination. Now, if I could write W as a combination of U and V, let us say the vector W is kind of like this, right? So what I could do is I could place this vector here, and then as you can see, we can actually form a linear combination of U and V to produce W as a diagonal of a parallelogram. So if I draw a vector parallel to V, for example from here, right, so we get this vector parallel to V, and another vector parallel to U, kind of like this, then you can see that we have two vectors here. This particular vector is parallel to V. I could write this as A times V. The other vector here is parallel to U, right? This is parallel to U. I could write this as B times U. And a combination of these two is the vector W, right? As you can see here. You could write vector W as equal to linear combination of these two. That is A times vector V plus B times vector U. So when you can write a vector as a linear combination of the other two, we say that the three vectors, in this case U, V and W, are coplanar. Right? So that is how the linear combination comes into picture. Now, scalar triple concept. When we say scalar triple product, we are actually trying to figure out what is, let's say, W dot U cross V. This is what we're trying to figure out. Now, if they are in the same plane, let's assume as they are in the same plane, in that case, what is going to be U cross V? What is going to be U cross V? Now U cross V will be a vector which will be perpendicular to plane of the paper, right? So I could always show this vector as kind of like this. So this vector becomes U cross V, correct? See, if I move from U to V, then like a right hand screw rule, it will move upward. So we get U cross V, which will be pointing up from this paper. making an angle of 90 degrees with the paper itself. So it is perpendicular to the paper. Now, if W is on the paper, then W dot U cross V will be equal to 0. Perfect. Since W is also going to make 90 degrees angle with this normal to the paper. So that is a very good way to verify if given three vectors are coplanar or not, right? So another way to figure out whether the vectors are coplanar or not is we could always figure out what is the triple product, which we call scalar triple product. So dot product of W with the two vectors. If that is 0, that means the three vectors are coplanar. Correct? So we have basically understood a couple of strategies here to figure out whether the given vectors are coplanar or not. We are going to use these strategies in solving many multiple choice questions. Now these multiple choice questions could be very tricky at times and lengthy. We will see how to solve them using the strategies learned. So let's take up the first strategy, which is linear combination strategy. We have an example here. Given two vectors U equals to -1, 2, 1 and V equals to 3, 1, 1, does the vector W lie on the plane determined by U and V? So what we are given here is vector U is equal to -1, 2 and 1. Vector V is given to us as 3, 1, 1. Vector W is 3, 8, 5. Now if W lies on the plane defined by U and V, then we should be in a position to write W as a linear combination of U and V, right? So we could write this as A times, let's say, vector U plus B times vector V, right? So that should be possible. So basically what we're trying to say here is that vector W, which is 3, 8, 5, can be written as scalar multiple of vector U, which is -1, 2, 1, plus B times 3, 1, 1. Right? So we have to find the value of A and B, which can make this linear combination true. So that gives us minus A. So we could write this as minus, if you add this up, minus, or you could say, okay, let me do it in two steps. Minus A plus 3B, that is the I value. Then we have 2A plus B, and then we have A plus B. Is it okay? So these are the three things. That should be equal to 385. Perfect. So that tells us that 3 is equals to minus A plus 3B. And 8 is equal to 2A plus B. So we get three equations. 5 is equal to A plus B, right? We can solve these equations, get our answer. So if I use these two equations, let us say, let me call them as equation 1, 2, and 3. And if I do, let us say equation 2, take away equation 3, then what do I get? So we get 3 equals to A, right? So we get the value of A as equal to 3. Now if I substitute A equals to 3, let me call this as my equation number 4. And if I sub equation 4 in 3, I get the value of B, correct? So we could write this as 5 equals to A is 3 plus B, and therefore 5 minus 3 equals to B, which is 2. So we get the value of B as equals to 2. So that gives us a linear combination. So we could write W the vector W as A is 3 for us, 3 times the vector U plus 2 times vector V. Do you see that? So if you could do that, that means they are in the same plane, right? They are in the same plane. And therefore, since we can write like this, we can say they are coplanar. Right? So this is a good strategy if you have to just verify whether a given vector is a coplanar or not. And that's how you do it. So basically you get 3 equations, work for them, and isolate 2. Important thing here is to check, which I didn't do. Let me now check. So it was kind of incomplete. We need to check with our first equation. That should be true. So we'll substitute A equals to 3, B equals to 2 in equation number 1. So we have, on the left side, we have 3. And on the right side, we have minus A plus 3B. If I substitute here, minus 3 and 2 times 3, then what do I get? I get minus 3 plus 6, which is equals to 3, right? So we can see that the left side is equals to the right side. Is it okay? So we verified that these values are perfectly fine. That was important to do. And now we can say that the vector W could be written as this. Is it okay? So that's how we do it. Now let's see and understand how to do the same thing using scalar triple product. Okay. Now the question here is, given 2 vectors U and V, verify if the vector W lie on the plane determined by U and V, right? So in this case, we don't really have to write it as a linear combination. We just need to verify. So from the concepts which you have learned, we can say that W is on the same plane as defined by vectors U and V if scalar triple product, that means W dot U cross V, is equal to 0. Correct? So what we can do is we can find the cross product of U and V and then dot product with W. So let's find U, V cross product. So we have minus 1, minus 2, 1 cross 3, minus 1, 1. Now there are different strategies which you use to do the cross product. You can follow the method you have learned, right? So one of the methods is that you just write these terms as let's say minus, starting from the middle, minus 2, 1, minus 1, minus 2. And the other vectors starting from the middle, minus 1, 1, 3, and minus 1. And then to find I, J, K, their components. These are pluses, these are minus for I, right? Similarly for J, and then for K, correct? So what we get here is that I times minus 2 times 1 is minus 2. Take away minus 1 times minus 1, which is 1, plus J times 1 times 3 is 3. This and this will give me plus 1. And that gives me plus K times 1 minus 6. Minus minus becomes plus 6, correct? So we get this as our cross product, which I could write as, let me write down on the right side. So we get minus I plus 4J, and here we get plus 7K. Okay, that is what. Now let's do dot product with W. W is, so we'll do dot product with W, which is minus 9, minus 4, 1 dot. We can write this as minus 1, 4, 7. So minus 9 times minus 1 is 9. and minus 4 times this is minus 16, and 1 times 7 is 7. And that indeed is 16 minus 16, which is 0. Now, since the scalar triple product is 0, we can say they are coplanar. Correct? So I've used this particular way of finding the scalar triple product. I'm going to use different strategy in the next example to find the scalar triple product. But I hope you understand how fast and easy it is to really verify that the three vectors are coplanar or not. Correct? Now these are your test questions based on the concepts we have learned about coplanar vectors. The very first question here is, which of the following vectors is coplanar with 1, 0, 0 and 0, 1, 0? So there are 4 choices for you. Now you could use one of those two strategies, linear combination or scalar triple product. But here is the third strategy. Let me show you that. So this third strategy could be used sometimes. Could be used only sometimes, okay? This is important. The vectors given to us are 1, 0, 0 and 0, 1, 0. Now, what do they represent? So if you kind of see them carefully, 1, 0, 0, let's look into our XYZ plane. So in this plane, 1, 0, 0 is the vector which is unit 1 in X direction. 0, 1, 0 is this vector. So basically these two vectors define XY plane. Do you understand? So these two vectors define XY plane, right? Or Z equals to 0. You see the value of Z is 0. So that really means that any vector in this plane will be coplanar. Any vector in this plane will be coplanar. So that comes from the concept. So at times, based on your knowledge of vectors, you can straight away pick an answer. So you're looking for a value where Z is equal to 0. Do you get the idea? So if you scan these 4 values, option C is the right option. 2 minus 3, right? So this is on XY plane, right? I mean XY plane. So that becomes coplanar to the given vectors, correct? So that is how you're going to answer this particular question. Do not use the strategies of linear combination of scalar triple product, right? Now here is another question. The question is, if the three vectors 1, 2, 4, 3, 4, 2 and 7, 8, k are coplanar, find k. We are given 4 options. Now if they are coplanar, then we can say that the scalar triple product equals to 0, correct? That is to say 1, 2, 4 dot 3, 4, 2 cross 7, 8, k equals to 0. Perfect. So that is what it is. So what we'll do is we'll do the scalar triple product. This time I'll use a different strategy. So we could always write it in the matrix form. So we'll say 1, 2, 4, 3, 4, 2, 7, 8, k, and we equate this to 0. Find the value of k, correct? So we'll just calculate this. So let's do it. So we have 1 time 4k minus 16 minus 2 times 3k, 7 times 2, 14 minus 14, plus 4 times 3 times 8, 24 minus 28 equals to 0, right? Now that gives us, let's open the brackets now, 4k minus 16, here we get minus 6k, and that is plus 28, and this is minus 4, so it gives us minus 16, equals to 0. Now 4k minus 6k is minus 2k. We get minus 16 and minus 16 as minus 32, and minus 32, and when you take away 28, so 2 plus 2, 4 we get, right? So we get minus 4 equals to 0, right? So minus 32, and so we get minus 4 equals to 0. Taking 4 to the other side, we get minus 2k equals to 4, or k equals to 4 divided by minus 2, which is minus 2. So option D is the right option, correct? So those of you who know this method, that's fine. Otherwise, you can do cross product and then dot product, equate to 0, find the value of k, right? That's the whole idea. Now let's take up the next example. Now the example here is, which of the following vectors is coplanar with 1, 1, 1 and 1, 2, 3? 4 choices are given to us. As you can realize, writing linear combinations is very difficult for all 4. It is very time consuming. Scalar triple product is still the best way to go for, right? So we'll again use scalar triple product equals to 0 for coplanar, right? So we'll have to do one by one for all of them. So let's do with 4, 2, 7 first. So basically what we have here is, what we can do is we can do the cross product between these two and then dot product with them, right? So let's do cross product of 1, 1, 1 with 1, 2, 3. So, well, let me do it in this matrix form, which is, I could write this as ijk, right? 1, 1, 1, 1, 2, 3. And that gives me, let me write here, that gives me I times 3 minus 2 minus j times 3 minus 1 plus k times 2 minus 1, right? So these are ijk xyz unit vectors. So we get 3 minus 2 is 1, so I. 3 minus 1 is 2, so minus 2j. And with k we get 2 minus 1 as 1, so plus k. So that becomes the cross product between these two. Now we are going to do dot product with each one of them, and whichever gives us 0 will be coplanar, right? So let's begin by doing the dot product with 4 to 7. So let's do 4 to 7 dot. This is 1 minus 2, 1, correct? That gives us 4. 2 times minus 2 is minus 4. 7 times 1 is plus 7, and that is not equal to 0, correct? The other one is 3, 1 minus 1 dot. Cross product was 1 minus 2, 1. So we get 3 times 1 as 3. 1 minus 2. Minus 1 minus 1. This is minus 1. This is equals to 0. And therefore, B is coplanar with the given vectors. Do you see that? So this is probably the fastest way of getting your solution. Let's try one more using the same strategy. The question here is, which of the following vectors is coplanar with 1, 3, 4 and 2, minus 1, 5? Again, 4 choices are given to you. You can actually pause the video now, copy the question, solve, and then check with my solution. So what we will do first is, we'll do cross product of 1, 3, 4. Right? You know the strategy now. So let me do it in a different way this time. Some students write the center term first, 3, 4, 1, and 3. Same thing here, center term first, 5, 2, minus 1, right? So when you do with this method, cross product, in that case, the terms which are these, they get added up, and you take away those ones, right? So these get added up. So this is for I, then we'll do for j, and k, right? And the terms which are in the reverse direction, we have to subtract them, right? So these ones are subtracted, correct? So the cross product here is, you can write from here, I will be 3 times 5 as 15, take away, minus becomes plus, right? And 4 times 2 is 8 plus j. 4 times 2 is 8 minus 5 plus k. So these are unit vectors along I, j, k, x, y, z axis, right? Minus 1, and that gives you minus 6. So this vector basically is 19i plus 3j, and here we get minus 7k. We are looking for a dot product with one of these to get the solution. Is it okay? So let's do it one by one. So with 3, we can write this first. 19, 3 minus 7 dot, let's say 327. 327. Okay. So you can use the calculator. So we'll straight away do it on the calculator. So 19 times 3 plus 3 times 2 minus 7 times 7 is 49 equals to, this gives us 14, right? So next one is, we'll do again with 19, 3 minus 7 dot 329, right? Figure this out. So we have 19 times 3 plus 3 times 2 minus 7 times 9 equals to, that gives us 0, right? Since this is 0, we know the answer is 329. Do you get an idea, right? So that is probably the fastest way of doing it. So I hope with this you have learned the strategy of finding coplanar vectors. Feel free to write your comments, share your views, and if you like and subscribe, that'd be great. Thank you and all the best.